So when we think about geospatial technology, one of the things that we're really looking at is a lot of technology, different kinds of technology, but also special kind of information. Okay, and so the technology can be GPS units. It can be computers, now tablets. I think the cloud, wireless connections. What else? There used to be a pen, a GPS pen, that you could take a tablet, a PDF of an image that was georeferenced, which means the image had coordinates in it, and you could go out and just draw on that image, and it would create polygons or points. And I think they're still working on it. It was out a few years ago, somewhat successful for people, but it was like, wow, you don't have to have a GPS, collect points, go back in the lab, put them into the computer. You could just create your data right there in the field. And tablets now let people do that. Springfield, their Willamette GIS department, which was phenomenal, had all of their work orders on iPads. All of the workers had iPads. They would go out, they would type in the locate, or they would put a dot where they were. They would write in what was broken or what was needed fixing. That would automatically go to a work order, which would get sent out with the location and the lat long. It was just kind of phenomenal how that's changing our work world. In the video, she talked about remote sensing, right? So those are satellites that collect images and other data of the Earth's surface. And what other surfaces are in the news lately? Mars, yeah, they found water. They found water on Mars using satellite imagery and remote sensing. Pretty cool. The information for a GIS has to be special. So it's special spatial information. And what makes it special is that it's spatial. And what that means is there is some kind of location, and it's absolute location connected to the information. Because unless I have absolute location in the form of a latitude and longitude or a UTM coordinate or an address, I can't put it on a map anywhere, right? So you can also have spatial information that is a polygon. So the shape of Oregon, every line has, or every vertice or line or dot as you go around making the shape of Oregon in a map has a latitude and longitude coordinate, and that creates that shape of Oregon, that polygon, and then there can be a lot of data associated with that polygon. So we can have, what the predominant political party is, what the overall economics is, what the population, right? So you have all that information embedded in any kind of shape, polygon, line, point, or in an address. And so that's what you need. You need the technology, but you also need information that has some kind of absolute location associated with that. And did the reading go over relative and absolute location a little bit? No. Okay, so I will do that. In fact, I will do that right now. So probably a hint about what is absolute location. Anybody have an idea? Okay, yeah. So some kind of lat long coordinate, some kind of address, other kind of coordinates, UTM, state plane. GPS would have a lat long with it, so you would get your lat long from a GPS. Great. Yeah, so all of those would be what we call absolute location. Okay? And so the other type of location is relative. So I don't know. What do you think, Joe? You're looking at me very suspect today. What do you think relative location would be? If these are absolute, what would relative be? Okay. He used cardinal directions, right? North, south, east, west. So relative location would be partially what you said. It would be giving you a location relative to something else, right? And so relative location would be, you know, my house is south of Willamette. Oh wait, can't be south of Willamette. My house is south of 29th, right? So I'm giving you a relative location. Maybe my house is 6 miles west of LCC. Those are all relative location, right? So with respect to another A-N-O-T-H-E-R place, right? And you use cardinal directions for that. Which are like north, south, east, west, that kind of stuff. Okay. So why would it be preferable to use north, south, east, and west rather than my house is left of PC Market? Right, left is good point. Left and right are relative to whichever way I'm facing cardinally, right? And so it can change. So if I give somebody directions, you know, left, right, they can be misconstrued. If I want to change and go the other way, come from a different direction, then I have to kind of rethink that. So when giving directions or describing places, it's really useful to use north, south, east, west rather than it's in the top of the map. People often do that. They'll describe a location in a map. It's in the top of the map. It's on the left side of the map. But, you know, that's assuming north is up, but north isn't always up. It should be, but it isn't always, and it should be only because I'm Eurocentric. So if I were from South America, I might think south needed to be up. I don't know. So anyway, when we talk about places and we describe things, we're going to try to use absolute location in conjunction with relative location. Okay, so this little segue. Okay, functions of maps. All right, one of the things the book said is the function of the map is to communicate geographic information, right? And so we've already kind of beat that horse to death. The geographic information is information that has some kind of spatial component, right? And it's on that paper medium or that medium of a map, media of a map. All right. Okay, so I'm going to have you, I gave everybody a piece of paper. And one thing I want you to do is to just draw your mental map of Oregon. You've got 5 minutes, okay? Ryan? Yeah, generalize. There it is. Yeah. So how did anybody generalize their map? I think you said it, Michaela. You just did some of the cities. Right? So, yeah, you didn't do all the cities, right? You don't have time. You just didn't do all of the mountain ranges because there's the whole Wallowas, and I didn't see much of that. So all of those things go into making a map. They don't all have to be there, right? I think they listed 5 in the reading, and they said you got to have at least one of them, and I would say more than one. There's a lot of discussion about north arrows, whether they should be on a map or not, and we're going to put them on maps because it's good practice in learning how to put in a nice looking north arrow that isn't the focus of your map. So new cartographers make giant north arrows where when you open the map you think, oh, there's the north arrow, but that's really what you see first, which is not the goal of your map, right? So we'll look at that. So this is one of the things they talked about, that oblique view as opposed to that aerial view and not a profile, and I'm still not sure that you couldn't, how much oblique is it considered oblique and then it's a profile? I don't know. I think we're really pushing on that one. Does everybody know the term as the crow flies? Okay. Yeah, so that's kind of going from one place to the other as if you didn't have to go across topology or around roads. It's just that direct line. And that's part of that geocentric view that we have that also makes it possible for people to make maps and interpret maps, right? We have to have that. Okay. And we use maps because why? Oh, no. They're convenient. They're always true. Right, right. One of the questions that stumped people, a well-developed, powerful image map is a really good map. Not always. Sometimes that's a propaganda map. Sometimes that you get really swept away by the glitz and the color and the beautiful imagery, and you find it's, whoa, wait a minute, that's not, the data's not right. I had a student several years ago who did this amazing map project defining how much area was available to do rooftop gardens in downtown Eugene. So she had to do a lot of digitizing, copying the areas and making shapes of that. And then she extruded the buildings to 3D so she could show this really beautiful 3D model, and she added all these graphics. And we were blown away at her presentation. And do you know how much area is available for rooftop gardens in downtown Eugene? She found 1 square foot. And we didn't read that in the fine print. She had a math error, a major math error. And basically she was doing her project in a geographic coordinate system that does not have units of measurement. Everything's in arc degrees of longitude and latitude. So when she did her calculation, and what was happening with that is that her brain was so into the cartography and so into the visual impact of the presentation that she forgot to look at the data and make sure that it made sense, you know. And that's, I mean, lots of times you'll look at a beautiful map and then you think, wait a minute, what is that? And when they're beautiful maps, you tend not to read the fine print, right? People get easily swayed by lovely. Anyway, okay. So I wanted to show you this table of salmonella outbreak in 2009. And you can see there are some states who were not as lucky as others. Let's see, Kentucky didn't do so well, and Montana did great, so did Oklahoma and Maryland. So what kind of things does this table make you think about or make you want to discuss? You know where I'm going, don't you? Cody, right? Colin. Dang it, that's another C, though. I'm getting close. Okay. Okay. So you kind of want to know what happened, Chad. Okay. So that we're going to assume those were 0. Scott. Oh, good point. Okay, so terminology. Great. Okay, so you asked a lot of detailed questions about the data. Kimberly? Yeah, it was one case. One person had salmonella. Right, right. Ah, a good point. I do not know. I think cases are usually a person, but that would be my assumption. But I would hope there would be data on the table somewhere that would tell me that. I didn't have the data because what I had was the map. And what I want to demonstrate is this is a choropleth map. And in this map, and we'll talk more about this, the color is related to the value. So the lighter color is less incidence of whatever I'm mapping, and the darker color is more incidence. And by doing that, it means I don't have to go back and forth to the legend to kind of interpret the map and get some information from this map. So I can look at this, and now I can think, you know what, my guess is the Montana and the California outbreak were not related to this outbreak. Because on the map, I can see the spatial distance between the two. That would be my first guess, right? And then West Virginia is weird. I don't care what you say. West Virginia is a weird place. And on any social map that you make, West Virginia is one of those things that is not like the others. I don't care what you map, it's different. And there's a lot of reasons for that, and one of them is their physiology. They are a very isolated little state with lots of dense terrain and hollows and hollers, and anyway, so segue. Okay, so, but I think by looking at a spatial representation of that data, you get a lot more information and you ask a lot more questions, right? So I'm thinking, gosh, this looks like definitely would be kind of the center of that outbreak. It's interesting how it jumped. Here's Alabama, which is different than Georgia and Mississippi. So there's just a lot of information that you get from a choropleth map that you wouldn't get from if this were in red, green, and blue colors. It would be really hard to see that pattern as well. And it would be a bad choropleth map. Okay, so they spent a lot of time talking about relative. Oh, I already did that. See, I knew it was in here.
I have a question about that last map.
Okay.
For the chloroplast map, is it always in like gradations?
Yes.
Okay.
Yes. It's always in gradations of the same color unless they'll do a bivariate, and I'll show you that sometime, right? So below the average is yellow and above the average is blue. Okay, so they'll do that. Yes, Brian?
I what the question was on the choro.
Yeah.
Uh-huh. I don't know about you. I read the thing printed out.
Uh-huh. And it's not in color. Nice. Yes. Yeah, yeah. When they're in color, you can see that they're very different. Right. Okay. Yes, sir.
How does that differ than, say, this here thematic map?
That is a choropleth map. That would be another example of a choropleth map. A choropleth is a type of thematic. Okay? All right, so we'll get more into thematics in just a second. Yes. Now there's one where you have two, the brown to white in the textbook, the kind of brown to white and then the white to blue. And so that's also, yeah. It's really difficult for people to differentiate by more than 4 or 5 colors sometimes. So if I want to show a high and a low range, sometimes they'll use that 2-color, like my average is here and then above the average is one color, below the average is another color. So I've got some examples of that too. Okay, so this is a reference map. Would we all agree on that? Yeah. There's probably trying to have spatial accuracy. There's not really a theme, although I could make a case that there is a bit of a theme or that some features have more value than another. Anybody see that? Yeah, I've got kind of an implicit theme of big roads to little roads. But they're really, and I could infer the distribution, right? I could say, oh, there's lots more little roads and the big roads are in the center. But that's not the purpose of this map, right? That's just some extra information. So on that continuum of a reference map, this is a reference map and it has some elements that you could argue could make it somewhat thematic. Another reference map, right? So I've just got the major roads. I've got the countries are bigger, so I guess that could be a theme. But mainly, they're not trying to show you anything thematic on that. Topographic maps are also thematic maps. No, wrong. Reference maps. And again, you could actually argue that the elevation can be inferred, as themes, right? High elevation, steep elevation. You could figure that out. Okay, so thematic maps show that geographic distribution, and the book says they focus on one theme, and in reality, they can focus on many themes. You can have what's called a multivariate map. So you can have, population plus disease on the same map using different kinds of symbols, all right? And if they show numbers, it's a numeric map. If they can show categories of data. They can show data that is ranked, highest population, lowest population. So there's all kinds of data that can be thematic, but it all stemmed from either some category or type or some population thing. So this is a categorical map. It's thematic. It's showing you vegetation. From this map, I can see the different types of vegetation. So that's my theme, right? You could argue that in some ways it's a reference map. You know, so they would have elements of a reference map because there's no numbers behind this. It's not showing me the actual distribution in area explicitly. It's kind of inferred. But primarily, this would be a categorical map. This is, what is that? Are those categories? Where would we do that? Yeah, it's just a reference map that somebody colored with different colors. So there's no categories, right? If we did a regional map, right? So the Northwest was colored 1, all the states in the Northwest were colored 1, that would be a categorical map. But this is just a map, a reference map. Okay, this is called an ordinal map. Okay, so they took actual data. It's a thematic map, so my theme is car pollution and car sales, and they did a tax system to tax cars that had less emissions, and I guess this will change after the Volkswagen thing. Okay, so they made a map, and then they ranked them as good, average, and poor. All right, so it's based on data, and then they gave that data range a category or an ordinal ranking. Okay, so they're all thematics. All right, so here is a map based on numbers. This shows the percent of population in the U.S., the United States, and Puerto Rico. Percent change of population, so how much the population changed over time. And it's a great choropleth map. I've got light green is 0 to 9. Gray is decline in population, although this is really bad. I just saw this. Anybody know why this would be bad? Yeah, because they've made Canada and Mexico gray, which Canada, yeah, so what you really shouldn't if you're going to use gray in your color scheme to mean something. So that's bad. They should make that white or something. But anyway, I never saw that till right now. Okay. Okay, so again, the choropleth map we looked at. Here's another example of a choropleth map. So just looking at this map, you don't have to go back and forth to see exactly the percent. You can look at the pattern, right? You can say, okay, high, low, just based on the colors that they've chosen. So I can see that there are not a lot of young'uns, meaning you guys, right here in the middle of the country, right? Not a lot in northern Idaho, and there might be reasons for that. And not a lot in the thumb here, or in the mitten, right? So, but I don't have to go back and say, what color is that? What's that related to, right? Choropleth maps are really, really handy at helping understand the map and make conclusions. This is one I talked about having 2 scales. So there were too many categories to use one color scheme, so they had to kind of go light to dark green and then light yellow to dark red. And you can really see I-5 running down the middle of the state. Okay. This is a bad choropleth map. This is not a choropleth map. This is a bad thematic map, right? So okay, I'm going to assume red is always the most, right? So in that area, I'm right here. Okay, so whatever this is, red is the most. But what is blue? I would think blue is the next intense color. My just instinct would tell me the lightest color is the less. And so this is a really bad choropleth map, or bad thematic map. I have to keep going back and forth to this legend to kind of interpret the results of what's on this map. Discrete colors like this are great for categories, right? Yes, Bill? Yeah, and that's a huge issue. There are certain colors that you can use for colorblind map reading, but depends on the extent of the color blindness. So in that case, patterns would be good, right? So a choropleth map of patterns would be light dots if it's low, and really heavy solid hatch lines if it's high, and then, grade that pattern in between. And so that's often, that's a real concern for making maps. Yeah, yeah. Thanks for pointing that out. Okay. Did you have a question, Chad?
Oh, no, I was just talking, I think about what the colors that they used on there, the order that it goes in is the same as like color wheel. So
That's
kind of
true.
going
That's true.
from
Yeah.
red, orange, yellow, so on and
That's
so
very nice. Yeah. Okay, and here's another one. Yeah, same idea, right? All the colors. And I can see that, I can see a pattern in the yellow, but I don't really know what it means until I go back and look at the map. So these are easy to fix to make them really elegant. The data's probably fine, but when I look at stuff like that, I automatically assume the data's not any good either. It's like so one of the things you don't want people, well, that's probably a really bad thing to tell you, but you don't want people spending a lot of time questioning what you did. You want it to be clear, and you want it to look kind of valid. So if I'm slowing people down at all, having to go back and forth and read and try to figure out what I've lost my audience. Okay. Here is another example. This is a graduated symbol, and in a way, you could use this as a multivariate map, because I can look, the size of the symbol is the population, and the size of the country shows me the relative area. So I can look at countries like Chad has a smaller population for its size, right? And South Africa has, or is this Nigeria? Yeah, huge population in a small country. So this gives you a little bit more information about the map than you might have. Another kind of map that I want you to be able to talk about is a cartogram. And a cartogram takes the shape or the area of a feature and extrudes it, so makes it tall, or squishes it depending on some value. So the value here is the population change in these provinces in Canada. So you can see that this province had a lot of population growth, and these had a lot of population loss, right? So it's a nice visual, right, that just kind of gives you that added kind of third dimension. These are some of my favorite cartograms. And this one, I think, is population. And so they took the shape of the country or the area of the country, and they either made it larger than the average or smaller than the average. So they used the average country population as the base, and then made the country itself look larger or smaller. So you can see that Australia, the area. Australia has very little population for its area. Canada is almost non-existent on this map. A lot of area in Canada, not much population. India is huge, relative, right? And China, Japan, South America, U.S. looks kind of normal, but maybe we made the map. Who knows? But these are all cartograms that kind of give you a different perspective. Okay, this is bad in a couple ways. One is this map is not projected, and so the shape of the United States is kind of long and narrow, and it just looks funny. And you'll see a lot of maps out there that look like that. The dots, there's too many ranges here. I can't really distinguish. We're not very good at distinguishing volume as human beings, and so these two are different, but you would have to really want to use some micrometers and double check. Just too many ranges. 5 to 7 might be the most that you could really look at. Okay, propaganda maps. Here's one of my favorites. Japanese propaganda map showing how they were being encircled, and how they were being kind of at risk as a way to kind of promote the war effort. Okay. So one of the things that I know. I love this statement. Maps lie flat, so all maps lie. And that's not even very true anymore because now maps are on, Google Earth and on spherical media. But most maps that are on paper have some kind of distortion, and some lie deliberately. So I am not saying that this was a deliberate lie. Okay? But, so here is the Bush-Kerry election. And you can see from this map that Bush won, hands down. What's the beef? Right? I look at this. This is what was in the newspaper. Bush won. Why was everybody saying it was a close race? They were crazy. Oh, Kimberly, you're saying this is a bad map? She's right. Yeah. So this map could be conceived as propaganda, because if there were 51% of the vote in Idaho that went for Bush and 49% of the population in Idaho that went for Kerry, it's the whole state gets colored red. That's really powerful. It doesn't really show me what the breakdown was. This is part of what's called the MOP, the Modified Area Problem. Okay, so here it is by county. That gives you a little bit more sense of things, right? You can kind of see, whoa, wait a minute, that was all red, and here it's blue. But yeah, right. That's a good point, because that's just that's kind of, there's no population here, right? But they still got all red. Yeah. But let's look at it by percent of the population. And then you get this kind of purple country. It really was a very close election if you look at the percent of the vote. And this map, nice drilling. This map would have been, and I wish you could see my screen, but anyway, because it's much more purple than red blue, and so would have been a better representation on the country. So that's called the modified aerial unit problem. And so even though the same data was used in all three maps, you can see how mapping it by state, by county, or by percent really changed the interpretation, right? Made a huge difference in how that map looked. And so sometimes you can use a map to persuade people without really lying about the data. You just decide how you want to present the data, right? And the first map that we looked at was an accurate map. So anyway, this is a map showing the Muslim world. And I saw this in a textbook, and Israel is right here. It's blue, but you can't really see it, but that was the focus of this map. And it seems to me red is a very inflammatory, dramatic color. Blue is that true heart color. And so this would be a map that might be used to persuade people that Israel is at a disadvantage, or is threatened by the Muslim world. So if I made the map differently, and I mapped it by population, you can see where it puts Indonesia in perspective. So it's really not right next to Israel. They're kind of far away. If we map it by population, Israel shows up a little greater. If we mapped it by military power and money, Israel would be almost at the top. So just depending on what data you want to show, you can create a map that's very inflammatory. I like this one, map of the world during 1942, kind of showing how the U.S. needed to get into the war. This is a bit of a propaganda during the Middle Ages, and maybe not really propaganda as much as just self-centric. So we have, Europe in the middle. There's Africa over there. There's this ocean around us. Just interesting old maps. Okay. Where did my, oh shoot, Mercator, that's the one I wanted. So the Mercator projection was used in the Cold War, and it was used deliberately to show that the threat from the Soviet Union was great. And so they used a projection that made the Soviet Union as big as possible. And the Robinson projection would have been better for a global view and would have shown it a little bit smaller. And so let's see, have I got that? Let me see if it's still here. Yeah. No. Oh, shoot. Where is it there? Okay. Oh, it was that. And we have an advertisement date on it. Can we skip? In 2 seconds, yes. Okay.
Hi, I'm sorry. Oh, sorry to be late.
No problem.
CJ Craig?
Of course you are. I'm Dr. John Fallow, Dr. Cynthia Sales, and Professor Donald Hugh. Hugh.
Okay, and you are the Organization of Cartographers for Social Equality.
Well, we're from the OCSE. We have many members.
How many?
4,300 dues-paying members.
What are the dues?
And $20 a year for the newsletter.
Let's start.
Wait, I want to see this.
This is Josh Lyman.
Indeed you are.
Josh, this is Dr. Fallow, and his very men.
Yes.
Should we begin?
Yes. Plain and simple, we'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Give me $200 and it's done. Really?
No. Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas of the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But it distorts the relative size of nations and continents.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Blow your mind if I told you that Africa is in reality 14 times larger.
Yes.
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map, but it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
It has fidelity of axis.
Fidelity of position.
East-west lines are parallel and intersect north-south axes at right angles.
What the hell is that?
It's where you've been living this whole time. Should we
Stop
continue?
there. Okay. I just love that. It's like, oh man, that was so good. So there's another way to lie, either deliberately or not, with maps. Okay, come on. This one on. Okay. All right. So that pretty much covers the term or the reading. And so what I want to talk about is the lab for this week, Lab 1. And Lab 1 is really designed to kind of get you used to the other labs that we're going to do. So I do step-by-step tutorials that are pretty easy to do and easy not to learn anything if you just, click, 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 click and go through it. So as I said before, you get to bring those to the exam. So print them out, take notes on them, kind of things that you notice, things that you had trouble with, things that aren't clear, make them a document that you can use later. Image distortion. One of the reasons this lab is going to ask you to go onto the internet and get 2 maps hopefully of the same place, but if you can't find them of the same place, don't spend a lot of time doing that. One thematic and one reference map, and put them on a one-page Word document, and then just a short discussion about why the reference map is a reference map and why the thematic map is a thematic map. And part of the focus of this lab is when you do screen captures for me in the future, often students will distort the image by stretching it too big or squishing it up. So I want you to be able to put in an image that is not distorted. I also want you to be able to wrap an image so that the text goes around the image, so you don't have an image and a lot of text and an image and a lot of text. But the most, F-I-L, that's right? Yeah. The most important aspect of this is file setup and file management. And that is going to be a really difficult thing for people in the future, and it's a really important thing, that you know where your data is, that it's all together. And so I go through this really painful set up a folder, make a file. In that file, make another file. In that file, you're going to add a Word document. I want screenshots of your file setup, because when you get to ArcGIS and some of the other programs, where your data is critical. Okay, if you don't have a flash drive today, the desktop is not a good place to save things, because it has a program called I'm going to go